Hello, everyone. Welcome to our final presentation. We are GolfCoach AI, and we are dedicated to bring Princess Golf Coach technology to every player everywhere. To understand the meaning of what we have built, are not enough. So let's start by showing you why Golf Coach AI worth it.
This is Alex. He's trying his best, but feeling a little stuck. Sometimes the best help comes from someone who knows you well. Golf Coach AI understands your movement and guides you gently. Step by step, Alex begins to move smoother and more confident. And sometimes a small improvement becomes a shared moment. Golf Coach AI for everybody, for everybody.
The technology is exciting, but for a product to success, it needs a market. Let's dive into our research and the massive opportunity we've identified. I want you to look at this curve. What you are seeing here is perfect storm. Post-pandemic, golf isn't just surviving, it's exploding. We are now looking at over 47 million golfers globally, and they are not just playing, they are paying. We are tracking $4 billion in training aid spending alone. The market is massive and is hungry for new technology that actually works. However, despite the demand, the current state of most traditional golf analysis software on the market, like the computers you see here, is quite limited and manual. They are usually rely on users to manually mark keyframes, label body position, and identify swing faces by hand. It's tedious and inaccurate. So this leads us to voice of the user. We do some interviews. We centered our research around two core questions. What is your biggest frustration? Do you know exactly what you did wrong? But don't just take my word for it. Let's hear directly from one golfer we interviewed.
So, if you had to pinpoint the biggest frustrations with manual process, what would they be?
Probably two main things. So first is, the speed is really slow. So even with the experience, it's hard to find the top or impact precisely. So especially that is hard for student who want to take who is like kind of like a rookie player or you want the instant feedback. So that is kind of like too redundant for them. Um,
As you can hear, the demand for a better solution is real.
Okay, let me make an introduction. So the Golf Coach AI gives users guidance that is safe, actionable, and actually helps them improve. Most apps rely on static templates, comparing everyone to the same perfect swing. But our Golf Coach AI takes a different approach. We use reinforcement learning. Instead of forcing every user towards a single ideal form, the system learns from repeated practice outcomes, which adjustments actually improve consistency and reduce risk for the specific user. That's why we focus on injury prevention, fixing root causes, and long-term improvement, not one-time scores. And if you map the current market, there is a clear gap. One-time basic apps on one side and expensive human coaching on the other. Hardware-heavy simulators at the bottom. Our Golf Coach AI sits in the top right, phone only, but continuous and adaptive. It's not a cheaper coach, it's a different learning model. We intentionally avoid exaggerated claims. Our current results come from a small test, and I want to share a very typical beginner example. So the user B had no formal golf training. Early analysis showed two main issues: the low swing consistency and the significant head movement at impact. So instead of asking him to swing like a pro, the system focused on one simple objective: keep your head more stable through impact. So after practicing for 14 days, his swing consistency improved by around 20%. The swing score rose from 55 to around 80. And his own feedback was, for the first time, I know what I'm actually fixing. This is not a miracle, it's a repeatable improvement. From a system perspective, GolfCoach AI is fully software-based and cloud-native. That means no hardware dependency, continuous model improvement, and every new users help the system learn more. And next, we'll walk through how this is actually implemented on the technical side.
Okay, so let's go to show the core logic of our system, what we call the learning loop. First, the users upload a swing videos, and this gives the system a raw motion data without requiring any center or special setup. The video is then analyzed by the module pipeline, where we actually pose and motion feature and build a structured representation of the swing. On top of that, the system used a reinforced learning-based coach instead of just labeling mistakes. The RL models evaluates which correction would lead to the highest improvement over time. Given the user's current swing state and the training context, the output is a single prioritized piece of feedback, what we call the fix. As users upload more swing, the system tracks outcome over time, allowing the model to adapt feedback based on the progress. This closes the loop: observe, decide, feedback, then improve and repeat. So we know the system is designed as multi-service application. The front end is a React web app for the authentication, video upload, and the viewing results. The backend is a fast API service that exposes REST APIs, manage users, jobs, and the database access. The PostgreSQL database at the persist storage layer, which store the user's accounts, analyze jobs, metadata, and analyze results, providing a reliable source of closed service. And also, the systems include a dedicated model component responsible for the video understanding and the coaching logic. This component analyzes the uploaded swing video, actions motion features, and applied a reinforced learning based on policy to determine the most impactful feedback for the users. So why reinforced learning? So I chose reinforced learning as the core of this project because the problem I'm trying to solve is not just about evaluating a golf swing, but about guiding improvement through the interaction. In real coaching, there's really a single correction piece of advice for a given swing. What matters is that the player should work on the next, how that advice changed their motion, and how the coaching adapt over time as the player improves. Supervised learning works well when the goal is to predict a label or a score from the fixed input, but it does not naturally model this kind of sequential decision making. In this project, each swing can be seen as a state, each piece of the advice as action, and the quality improvement of the next swing as a reward. The system doesn't just output feedback once. It simulates a coaching section where advice influences future swings, and the future swings change what advice makes sense next. So reinforced learning allows the model to learn this dependency and trade-off, such as whether fixing hand stability first leads to the better long-term results than immediately forcing on hip rotation. This implementation reflects this idea directly, and the models observe biomechanical features extracted from video, like the coaching action simulate how those actions affect the swing, and the received reward based on the meaningful performance improvements. This makes the system interactive and adaptive, closer to how human coach actually works, rather than a static evaluator that simply tells the user what is wrong. And finally, this image shows a simple images from our application workflow. The interface represents three concrete action steps generated by our system. Users are encouraged to follow this step to practice and adjust their swing execution. After performing these suggested corrections, user can re-engage with the model agent by uploading a new video. This creates a closed feedback loop where the reinforced learning agent continuously evaluates progress, adapts its feedback, and guide the user toward improvement and a more consistent performance over time. And thank you all for watching.
Okay, thank you. That's our presentation.